In this video, we are going to see how we can find rref of a matrix in Matlab. Also, we'll see how to find the null spaces, left null space and right null space of a matrix, eigenvectors and eigenvalues of a matrix, and how to find the covariance matrix of a data. So first, let's start with finding rref of a vector. So suppose I have A is equal to 1, 2, 3, semicolon 4, 5, 4, 5, 6, semicolon 7, 8, 9. And I find rref of A using the function rref. Now, rref or reduced row echelon form is a special way of organizing the matrix by performing matrix operations until it reaches a specific structure. Now, when I hit enter, as you can see here, this is my original matrix and this is the rref of this matrix A. Now, here are the key characteristics of rref. There are leading ones in each row, then leading ones above and to the left of other leading ones are 0 are ones, and then there are zero entries below the leading ones in each column. Now, rref is useful for various purposes, including solving linear equations to determine whether a matrix is invertible, to find the null space of a matrix, and understanding the rank of a matrix. Now, to find the right null space of the matrix, we have the Matlab command null of A. Now, null of A will return the right null space of the matrix, and null of A transpose returns the left null space of a matrix. So, now an eigenvalue of a square matrix is a special number that, when multiplied by the identity matrix, produces a matrix equivalent to A scaled by lambda. So we have um, A times X is equal to lambda times I times X, where X is an eigenvector associated with lambda. In simpler terms, when you multiply the matrix by an eigenvector, it stretches or shrinks that vector by the eigenvalue. Now, eigenvectors, this X here, are non-zero vectors that, when multiplied by the matrix A, result in a scaled version of a scaled version of themselves. For so A times X is equal to lambda times X. So to find eigenvectors and eigenvalues of matrix in MATLAB, we have the eigen function. So when I type, so when I type U, comma V, and then eigen of V, this command returns two matrices or two vectors, two matrices which contains the eigenvalues and vectors of the matrix. So as you can see here, U contains the eigenvectors, and V contains the eigenvalues. So the first eigenvalue 16.1168. This column over here, this column vector over here, the first column corresponds to the eigenvector 16.11, eigenvalue 16.1168. The second column corresponds to the second diagonal element, and the third column corresponds to this eigenvector. So this is how you find eigenvectors and eigenvalues using the eigen function in Matlab. So eigen function returns two outputs. The first output is the eigenvector and the matrix of eigenvectors, and the second output is a matrix which contains the eigenvalues as their diagonal elements. Now we have the COV function to find the covariance of a data set. So now there are two types of covariance. So if I now, as you can see here, we have two equations for covariance: population covariance formula and sample covariance formula. The difference between the two is that in population covariance formula, we have just n in the denominator, and in sample covariance formula, we have n minus 1. So, and the COV function is used to um, find or return the covariance of data in MATLAB. Now, suppose I have data, say rand of, say, data is equal to rand 100 n 102, and to find the covariance I use the COV function. Now if I just type COV of data, this returns the population covariance, and if I want to find the sample covariance, I should add a 1 as the attribute, as an extra input into the function. So COV of data, this command over here will return the population covariance formula, and this command over here returns the sample covariance formula. So when I run this, so this is the population covariance formula, and this is the sample covariance formula. Now, even though these values are almost the same, but they are different. Even though they are same, they are almost same, but actually they are different. So this is how we find covariance of data in MATLAB. Now, a quick recap: we have the rref function to find rref of a matrix. rref is useful. It's a useful tool for manipulating matrices and solving linear systems. Next, we have null spaces. The left we find the right null space of a matrix and left null space of a matrix. Actually, this should have been the right null space, and this was the left null space of the matrix. So, yeah. A transpose, null of A transpose gives us the left null matrix, and null of A gives us the right null matrix. And then we have eigenvalues and eigenvectors, which um, tell us the behavior of linear systems. Then covariance matrices summarize the relationship between the variables. Now, so these concepts are interconnected and they are valuable while doing operations like doing various applications like PCA in data manipulation and data analysis. So that's all in this video. See you in the next video. Bye.